It's wrong sheet?
No, I don't know.
I got number 1 right.
No, I think it's the right sheet. I just didn't.
Okay, so when this shifts, this is a frequency of 1. When this shifts, which direction is it going in? To the right. How many units? Pi over 2. How many degrees? They're pi over 2, or pi over 2 radians. So pi over 2 is where I should start my cycle. So 1, the 0, the 1, the 0, the negative 1, the 0. There's my first full cycle. It's a continuous curve. So just go backwards, and then up, and then over, and then up. It's easier when they give you negative 2 pi to positive 2 pi, because then you actually can see a full cycle. You really can't see it. You look at this and say, that's a sine curve. But that's just because of the way they cut their window off. Their window here is just a little bit different. But expand it if you have to. Just so, I mean, that's how I would do it. I would do this, 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 and I would bring it up to here. This way I could say, I'm a little bit over. So we said, take this. For you guys that weren't here, this is a phase shift. This is no different than when we do this. When we move horizontally 2 units to the right, but because these are degrees, it's not exactly the same thing because we shift through angles. So we call it a phase shift. So we take this and we set this equal to 0. Then we take this and we set this equal to 2 pi. We want to see where does one complete cycle start and end. Yes, technically this is a continuous curve, but we always start here at the 0 and we keep going around unless we're negative and we go the opposite way. But so technically we want to see where would that first start be. So all you have to do is solve for the x. So it's going to start at pi over 2. Yep. And we're going to add pi over 2 over here. And when you're adding fractions, just convert this to the same denominator. So this would be the same as 4 pi over 2, right? Just like you do when you're naming your radians. And when I add this, I get 5 pi over 2. So my cycle goes from here to here. This is my first complete cycle. Yes?
I don't know how you know what 5 pi over 2 is.
Well, because separate these to pi over 2, right? 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. It has to go every 90 degrees. Didn't I shift at 90? So, and I didn't change your frequency. Your frequency is still every 90 is your quadrant. So I'm shifting this 1 quadrant over. That's all I did. If I was here on my unit circle and I'm doing a sine curve, I'm technically saying this guy, shift everything over. Start with my 0, my 1, but don't start it till you hit here. It's the same following around your unit circle. I always start here when I begin, but it doesn't tell me to start until I hit pi over 2. We have to have some kind of starting point so that we know where to start that new sine curve. We still begin this at the 0, but we don't place it until we start at pi over 2. So when you're doing radians, I find it the easiest just to convert your denominator so that you can figure out where the end and the beginning are. But just count this by pi over 2's, because this is 2 pi over 2, 3 pi over 2, 4 pi, 5 pi. Does it make sense? You guys that weren't here, does it make sense? You need one complete cycle. One complete cycle. It's a phase shift. I gave you number 2? Okay. Number 2, what does this 2 do to my equation? Multiplies it by 2. So my cosine says 1, 0, negative 1, 0, 1. I multiply everything by 2. What is this? Plus 1. Shift, vertical, shift, up 1. So I add 1 to everybody. 3, 1, negative 1, 1, 3. So, and my frequency stayed 1. Yeah, these are nice. Are you getting the swing of these? I threw a few of those in there just to, yeah. So 3, 1, The phase shifts, yes. You'll get used to those. Well, I'm not gonna hit you with too many. And we follow these numbers. And we graph. Okay? And your calculator handles this very nicely too, because it automatically goes to 90 degrees. It automatically deals with a frequency of 1. Those are your standard curves. The calculator, do it in degrees, and the only thing you have to make sure is that your table set is your period divided by 4, because otherwise you won't see it on your table. Yeah, that's the only difference there, which is what we do here anyway. We do our period divided by 4 to see where do our tick marks go. I like it without the calculator. Yeah. I'm not a real fan of the calculator for this. It's just like, especially if you do radians. Radians is a lot tougher. Are we okay with this?
Yeah.
All right. What was the next one I gave you?
4.
4. So what's different? What changed?
Pi over 6.
Oh, pi over 6 is how many degrees? 30. 30 degrees. Which direction am I going to go in?
Left.
Left. What's my frequency? So I'm still this. But where's my starting point now? Negative pi over 6, negative 30. So I'm just going to come back here. If this is where my 0 is, because it goes in the opposite direction. Remember, they inside the parentheses go in the opposite direction. So I'm just going to extend this to say negative pi over 2. Okay, so I have to change this to negative 30 degrees. It's a little bit strange. I'm really working on my 0, my 90, my 180, my 270. But now they want me to start at negative 30. So since you're in 30s, do all of your pieces like this. Cut everybody into 30s. Just, oh, it is cut into 30s? Oh, how come mine isn't? Okay. Okay, so cut everybody into 30s. Now, start at the 30, but what's your frequency? 1, which means your period says 1 curve and 2 pi, right? So your quadrants go every 90 degrees, still goes 90. So even though I'm starting here at the negative 30, I have to say, and go from here to, where am I? Negative pi over 6, I'm sorry, I have to extend it like this. Oh, I think, did I do it right? Yeah, I did it. Okay, so the first one should be here, and then I should go, oh, I should start at 1, sorry about that. I'm saying, why is that not right? So I'm here, starting at the negative 30. Just extend this a little bit. Be careful, this is the y-axis here, that's what looks confusing too. This is the end of their graph. I thought I was off with the end of my graph. But I don't know why either, especially when they ask you to start it at the negative side. I don't know. And then they cut this red line, so it makes it look like, where am I supposed to go? So start here at the 1, but you're going every 90. So 30, 60, 90. Just count 30, 60, 90. 30, 60, 90. 30, 60, 90. 30, 60, 90. And there's your graph. Your frequency is 1. That didn't change. Unfortunately, you're just going to have to extend this out here. Now, set this equal to 0. Algebraically, this is how we find this. Then we set it equal to 2 pi. So we subtract the pi over 6. So that's where we started. And that's exactly where we started, because we knew our phase shift went the opposite directions. Then we subtract pi over 6. Convert this guy to the same denominator. So just like you do when you figure your circle. So this ends at 11 pi over 6. And didn't it end just 30 degrees short of the 2 pi? And isn't that 11 pi over 6? Okay, so my cycle, my first complete cycle, goes from negative pi over 6 to 11 pi over 6. Sorry I have my back to you so much, but if I can't see where the marks are unless I stand on top of it.
I know you have 30 degrees, and then the period is every 90.
Not the period. The period is 2 pi. But 2 pi over b, because it's 1. The period is 2 pi, but the quadrants are 2 pi divided by 4, which is every 90. I didn't change the frequency. So when I come off my unit circle, don't I have to go every 90 degrees? I'll get you 1 second, Ashley. If this was a 2, it's going to change your phase shift. Not only will it change your phase shift, but it will change your frequency as well. Then it won't be every 90. It will be every 45. And it would change your phase shift as well. I won't throw that one in there. That's a tough one.
Is it, like, if we wanted to, like, for the test, if we had one of these questions, do it, like, how we used to do the transformations for the equations, like, do the original,
Yeah.
and then just highlight what it's just.
Yeah. Yeah, absolutely. I would just take actually in these, I would just take the final one. I find it harder to put 2 curves on these. And if you like that, I don't do it. This is the one time I don't do it with the phase shift, because what happens is you're going to start here and then go here. Like, it just makes it a little bit off. I mean, you can see the shift if you want to do that, fine, and then move everything in one position. I tend not to, because I go off of these anyway. So whatever you like to do is fine, whichever way you find it.
I was watching like videos last night, and the guy would make like tick marks, like with a regular cosine and sine.
Yeah.
And that's where I then just make like more tick marks, and then his final one he can actually draw.
Don't put too many tick marks in there. Use the tick marks that you need for this problem. Like this one, you do need a lot, because you have to go every 30. Because you're off. Normally we go every 90, and we still are going every 90, but we shifted and started to the left, so that made it a little bit tougher. Okay, what was the next one you had? 6. Okay, 6 has a phase shift.
Yeah, I did what? I did this one right.
I got this.
So which way is it going?
Go to the left.
Shift it down.
I thought you're supposed to stop, like, once it hits the.
Well, now don't forget, they're working in the window from 0 to 2 pi. That's not where it's already stopping and starting.
So I started at 5.
Okay, and you would go from negative pi to positive pi on this one. Their windows still go from 0 to 2 pi. Their window of graphing goes from 0 to 2 pi.
So am I supposed to stop at 5 or no?
No, if I were you two, I would, let me bring this out. Negative pi over 2, negative pi. That's why I said extend it if you need to. Your cycle says this. X plus pi is equal to 0. So x is going to start at negative pi. X plus pi is equal to 2 pi. So x is going to end at pi. And you're absolutely right. If I ask you where your first cycle occurs, you say negative pi to positive pi. However, they still graphed from 0 to 2 pi.
So am I
If,
supposed to start?
no. If you were comfortable doing this, where is this going? To the 0 up here, right? So yours looks like this. Yeah, that's absolutely fine. That's where your first cycle starts. But look, they only gave you a window from here to 2 pi. So if you start here, their window just went this way. I don't, like I said at the beginning, I don't know why they didn't give you the negative side. Because it's easier to start where we're supposed to start and where we're supposed to end. They graph enough to get a full cycle. Okay. Now this shift, also be careful of this shift, because that shifts you down 1. So start with this and shift down 1. And do those. Always set that up first. Did we have any reflections? No reflections in here either? Yes. Come on. Oh, it's open? Oh, I'm sorry. Yes, I had this open from yesterday. Okay, what was the next one? 7?
Yeah, we had like 7 to 10.
Okay, so 7. What are you going to do with 7?
No,
I don't know what to do with
he
it
just
either.
he just like distribute.
Yeah, why don't we distribute it?
That's what I did. That's what I
I
did.
did the math. I didn't intend graphics. Like,
Why don't we start like this?
just use the.
Oh, it's probably a lot easier. I should have done that.
Huh?
They should just use the 2 and the 2 frequency.
2 is the frequency. But in on here, but it's also got to be distributed over here because your frequency should be right here. So let's just see what happens. So this is shifting with direction to the right. C over B. Don't forget to flip these guys over. Reduces to what? Pi over 3. So where is our shift actually? 60 degrees. Every 60 degrees. 60 degrees is the hard one. Okay, so if I were you guys, I would also separate these into 30s. Oops.
They are.
Oh, on your paper? Oh, wow. Okay. It might not be on the answer key then. It might be on my original sheet, but not on their answer key. Okay, so I would, and again, I would extend this line, although you don't have to extend this line. All right, so now, let's figure out where we're going here. We have a phase shift of pi over 3. Which direction is it going in? To the right. So we're going to start at pi over 3, which is right here. Oh, that looks familiar. Sine curve. Doesn't it look like it's starting right there? Okay. Because this is 30, this is 60, this is 90. Well, yours should be, they said yours is separated by 30s also. So pi over 3, 3 goes into 180. How many times, Lily? How many times does 3 go into 180? 60. So that's your angle, 60. It's hard to transfer to radians and degrees, but just take that denominator and divide it into 180. So I'm going to start here, but my frequency is 2, which means I have to make 2 curves in 2 pi. So let's see where they're going. They're going to start here, and they're going to go, continue past this. They're going to go 60 degrees past this. Oh, it is extended? Kind of awful. No, I don't know. I'm not really sure what they did here because I think they took the original and just plopped the answer key over it. That's why they put the red box around it. Because you see, yeah, yours comes out underneath here. I don't know why they did this. I like the graphs, but the way they present it is a little different. So this would be 12 pi over 6. So somewhere at 13 pi over 6, you're going to stop. So this is where my 2 cycles go. All I need is 1 complete cycle. So all I need to do is go how many degrees? If I have 2 frequencies in 360, how many to complete 1 cycle? Yeah, think about it. 360 degrees. Let's not do the shift first. 360 degrees. I'm going to put 2 of them in there. How much to complete 1? 180. I still need 180 degrees to complete this. But I need to go start here, not here. And then I need to say, okay, I need to go every 60 degrees. I need to go every, 45 degrees? This is a tough one. Every 45 degrees. Watch where this puts you. Just watch up here a second. You might want to add another tick mark. Isn't 180 divided by 4 45 degrees? Because I still have to fit 2 curves in 2 pi. Let's take, okay, let me just do this. Sine curve. Here's my sine curve. How many do I need in 360? Just don't worry about this. How's my sine curve go? 0, 1, 0, -1, 0. 0, 1, 0, -1, 0. Isn't that how I would do this if it said this? Just that. No phase shift. Bless you. Everybody agree? We did this the other day. We took this, we divided these into 4 equal quadrants. How much was each quadrant? 45 degrees. So now you have to go every 45 degrees. You started at 60. Yeah, I know it's tougher. So watch. If this is 30, this is 60, isn't 45 right in the middle? I know, because it's a phase shift of 60 plus it's every 45 degrees.
How do you know it's 45?
Because we know that a frequency of 2 tells me your period is 2 pi over 2. Your period is pi. So how do your quadrants work? Divided by 4. Every 45. You knew this. You knew this, right? This is what we did the other day. Okay, so picture this. Just pick this little piece up and put it right, starting right here. It's just going to start right there. That's all it's going to do. But the only difference is you started at 60 and you have to go every 45 degrees. So in here, try to tick mark off this, and here's an easy way to do it without panicking. This is 30, 60, 90. That's half of that, right? This is my 90. Put another tick mark. Do this with me. This is 30, 60, 90. Let's mark off your 90s. 30, 60, 90. 30, 60, and I'm going to get a 90. Now, in between those, come in the middle of these and put a tick mark. This is every 45. These are where your marks go. 0, 1, 0, negative 1, 0, 1, 0, negative 1, 0. It works. Try not to think in terms of how many 45s am I going to have into 135, blah, 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 blah. Just use your tick marks. You're going to start here. Pretend this is your 0. Find your first 90. Cut it in half. Find your second 90. Cut it in half. Find your third 90. Cut it in half. Your tick marks are at every 45. All we changed was your starting point. I'm not asking you to tell me what angle is this. All I'm asking you to do is graph it. God bless.
Yeah, I still look at that.
What part? What part bothers you? Okay, so I'll do this one more time because I know it's confusing. All right, we agreed we're starting at pi over 6. Is that agreed? I erased it because I needed to erase it. So where is pi over 6? Oh, pi over 3. Was it pi over 3?
Yeah.
Okay, pi over 3. I knew it was over 60. Where is pi over 3? You do C over B. C over B for the phase shift. But we had to distribute this first. And doesn't it work out the exact same? Isn't it the same as if I didn't distribute it? Isn't it pi over 3 to the right? It works out the exact same if I didn't distribute it. And this is my frequency out here. But when we played in the beginning, I said, let's just distribute it and see what happens. It is the same exact phase shift. So without this, where are you shifting? Pi over 3 to the right. Right? Okay, so where is pi over 3? 60. How do I find it over here? Picture nothing on here. Oh, so I'm going to separate these into 30s, as is yours, you said. Okay, I'm separating this into 30s. And I have to start it at the 60, right here. Agreed. Okay, now, it has a frequency of 2. What does that mean to me? And how many 2 cycles into pi? Or let's just say 360 degrees. So how long does it take to complete one cycle? 180 degrees. Now how many quadrants do I have to go through in 180 degrees? 4. So I have to take this and divide it by 4. Just like you did this before. Remember you did this? And you said here, 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 here. Didn't you separate those into 45s? You liked it only because that was at the 90. It was 90 and you said half of that, 45, because it was visual. This is not as easy to visualize. So we have to do this every 45 degrees. Well, that's a little bit weird because I tick marked every 30 degrees. So where do I find 45 degrees? Where's my first 45 degrees if I have a tick mark at 30, a tick mark at 60, a tick mark at 90? Where's my first 45? In between 30 and 60. So in between 30 and 60, I'm going to put a tick mark. Okay, so let's make this easier first. Isn't it always halfway between the 90? Agree? Between 30 and 60? So now, let's just 90s. We're going to need the 90s anyway, aren't we? So how do I count 90? 30, 60, 90. Put a line. 30, 60, 90. 30, 60, 90. 30, 60, 90. Okay? Just tick mark off your 90s right now. Don't we take half of that? So now, without counting any degrees, I just want you to visualize this and this. Where is the halfway mark? Oh, I'm sorry, my board is off. In between, Lily told me in between 30 and 60. Yeah, there's my 45. Put a line. In between the 30 and the 60, up, put a line. 30 and 60, put a line. 30 and 60, put a line. These are the marks I'm going to use. 0, 1, 0, negative 1, 0. Those are the guys I'm going to use. All I did was take this curve that we did over here before and just pick it up and start it here. Try not to get hung up on what degrees am I doing. Try just to visualize where do your tick marks go. Same as they do here, every 45. Tick mark off your 90 first. And do it the same way you did this. You tick marked off your 90 and you took half a 90. Did you count and say, well, there was my 30, there was my 60, so there was my 45. You just said half a 90. It's a sketch. Half a 90. So find your 90s, put a tick mark in between them, and then you're going every 45 degrees to do a mark, a graph. That's probably the hardest one, because you're mixing 30s and 45s, 60s and 30s and 45s, because you're starting 60 degrees over. You got to tick mark by 30s to get that 60 degrees. You got to cut those into 90s, cut them in half, and get your graph. Your first complete cycle, all I need is one cycle, just goes from here to here. Just goes from here up to here. If you give me the first two, that's fine with me too. Okay. Hopefully that was the hardest one. What other ones did I give you? I gave you 8. Okay, 8's going to work the same way. 8's got a little bit more going on. So we got a phase shift. Now we can see that we don't have to distribute it. We can just see our phase shift like that, right? Doesn't it work out that we don't have to distribute it? Okay. So as long as you see that if we distribute it, we come out with the same thing. Where's my phase shift going? 90 to the left. I'm going to start at negative 90. I'm going to say this is negative 90. Okay, my cosine curve tells me I need to have 2 in 2 pi, right? This will be a little easier because we're at the 90, not at the 60. So if that's the case, I need 2 in 360. Therefore, it's going to take me 180 degrees to complete one. How many degrees is my quadrant? Every 45. Well, I like that better because now I can just divide everybody by 45s. Can I cut every 90 in half? Right? Doesn't that make sense? Okay, so now I'm going to start with my cosine. 1, 0, negative 1, 0, 1. And where am I going to put it? Down 2. So subtract 2, right? Try not to start like on your graph at 1 and then try to subtract 2. You'll drive yourself crazy. Try to do this first. So if I subtract 2, where am I starting? Then I subtract 2. Then I subtract 2. Then I subtract 2. These are the ones you want to follow. And how many times do we have to follow this? Twice. We have a frequency of 2. So here's my negative 90. I'm negative 1. Here's my 0. Here's my 45. Oops. What did we say? Every 45? This is technically my 45 because this is my 0. Negative 2. Then I go to negative 3. Then I come back up to negative 2. Then I come back up to negative 1. Okay. Do you see it? It's kind of hard to see. Is yours extended? No. Extend yours a little bit. Maybe it's easier to see that. If we start here, It's just that they keep giving you a window from 0 to 2 pi to graph, and it's easier to come out here. Then do it again. You're starting at the -1, then the -2, then the -3, then the -1, -2, then the -1. Here's my second one, right up here. So where's my period for a 2 cycle? From -pi/2 to +3 pi/2. I can kind of see that one right there. If I only need 1 cycle, I'm going from -pi/2 to +pi/2. Just take this, just give me 1 full cycle. Just take this, set it equal to 0, set it equal to 2 pi. Actually pi. Because 1 full cycle will just give you pi. And see where you come up to. Makes sense? It's easier for you to see the 45, isn't it? Yeah. Yeah. Well, what happened is you had a frequency. You had a frequency, so that made a difference.
Why didn't we have to distribute?
Well, we didn't, but because we didn't know where to start, I said, let's distribute it and see. So once we determine, yeah, it's the same difference, then you don't have to do this one. But when in doubt, does it look like something I should distribute? I mean, you guys are like, why is 2 out there? So we distribute it. It's the same difference. It's the same difference. And then what?
9 and 7.
You had 9 and 10?
Yeah.
Oh, yeah.
Yeah, 10 I didn't.
Okay, how did 9 go?
9 I did.
So C over B, which direction is this moving in?
Right now. 9.
Which direction? Left. C over B. What's B? 2. So you're starting at pi/2. Pi/2, which is negative pi/2. Negative pi/2, and again, let's just bring this out to negative pi/2. And you have to have 2 sine curves into pi. So again, you're going every 45 degrees, aren't you?
Yeah.
So just start with your tick marks like this. Just keep going every 45 degrees. Okay, so where does my sine curve? Do we have any shifts? Any amplitudes? No. So my sine curve starts at the 0, then it goes to the 1, then it goes to the 0, then the -1, then the 0. Technically, there's your first one. Then do it again. And technically, I stop here. All right, this guy, this is not so bad. Let's just talk about where this is and how to start this. So what's C over B? What's C? Pi/3, just give me this one first. Over what's B? 2. So how do I do that? Keep, change, flip. Make sure you flip this over. So again, now I'm going pi/6, which is how many degrees? 30. So how should I separate these little tick marks? Into 30s. I'm going to separate everything into 30s. Everything into 30s. How many of them do I want? 2. I'm going to start at negative pi/6, so maybe you just want to go over one of these little negative pi/6. And then start. Change your amplitude to 3. So 3, 0, -3, 0, 3. And add, is this add 1 or subtract 1? Subtract 1. 2, -1, -4, -1, 2. And follow those. Okay, starting up here, starting at this guy. And just remember, you need to go 45 degrees again. So see if you can block off your 90s. I know we spent a lot of time on this. I know this is the hard part. So go over this tonight. Go over this and work on the equation right. Yeah.
Yeah.
far is easier than the last part. Yeah.
I looked at that high, yeah, thinking 60. That's really very good. I don't know if you get it. I don't want to ask. Just get him off his mind. I'm gonna ask someone else. Hey Lily, you wanna ask Sandra? You hand the thing in late. Thank you.
Because there's this is located here. So cosine has to be positive, cosine is negative. Cosine is positive. So for that to be negative, the bottom has to be negative. Okay. But just for a place to go. Okay. And I look at all of your answers and do those. Okay. So I'd have to charge you twice for that, right? That one.
Okay, well, what are we doing today?
We're starting something else.